Vapor pressure is the measure of amount of vapor in contact with its liquid or solid form. And it increases with temperature. As you heat a liquid or solid, the vapor pressure will increase. And vapor pressure decreases with strong intermolecular forces. So the stronger the intermolecular force, the lower the vapor pressure. So here we have an illustration of what the vapor may look like above its liquid form. And vapor pressure is the measure of amount of gas above that liquid. All right, so here is a graph of pressure versus temperature for several substances, and sometimes it's a little difficult to make sense of these graphs. But something that's very important is the boiling point is defined as the temperature at which the vapor pressure equals atmospheric pressure. So the boiling points that we are familiar with are the normal boiling points that happen at atmospheric pressure, and our standard atmospheric pressure is 1 atmosphere. So if you read across that 1 atmosphere, the vapor pressure lines are associated with the boiling points. So these are the boiling points of the substances. This line is associated with water, so we see that the vapor pressure of water at 100 degrees is 1 atmosphere, or at 1 atmosphere we see it is associated with a temperature of 100 degrees. And then we have ethylene glycol, which has not even reached its boiling point on this graph. You can look at the intermolecular forces for these compounds. For ethyl ether, we're going to have an oxygen with some carbon groups here and the associated hydrogen. So this is a polar molecule. It has dipole-dipole forces. Ethyl alcohol is going to be a 2-carbon group with an oxygen and hydrogen, a hydroxyl group on the end. So this has hydrogen bonding. Then of course we have water. Water is nothing but hydrogen bonding. So this is sort of, you can consider it 2 points of hydrogen bonding. Because even though ethyl alcohol is a little bigger, you might think it has stronger dispersion when these have similar hydrogen bonding forces, but hydrogen actually has more, or water actually has more points of hydrogen bonding contact. And then ethylene glycol, I won't draw the complete structure, but it has some carbon and hydrogen in the middle, and it also has 2 hydrogen bonding groups. So when you compare water to ethylene glycol, they both similarly have H bonding, or 2 points of H bonding, but this one is bigger, and so it has stronger dispersion. Or the dispersion forces enhance the dipole. The size of the molecule enhances the dipole and attractive forces in the hydrogen bonding. So that is why ethylene glycol has a much lower vapor pressure than everything else. So at a specific temperature, for example, here around 38 degrees, you can compare all 3 substances in their vapor pressure. So water has the lowest vapor pressure because between these 3 substances, it has the strongest intermolecular forces. Ethyl ether, or diethyl ether, has the weakest intermolecular forces, and so it has the highest vapor pressure.